the way I typically am going to lecture, real quick, we're going to go through what we did. Make sure everybody remembers. Then we'll hit the new tissues, okay? Now, we went through last time the beginning. We did epithelial tissue, and then we did the first part of connective tissue, right? Where do we commonly find epithelial tissue? Okay, the skin, outside of the skin is epithelial. Is that the only place you have epithelial tissue? Lining of any type of canal in the body. Any area where you're going to see abrasion, meaning something is going to be rubbing that area, you usually are going to see epithelial tissue. Why does that make sense? I'm constantly rubbing right here. What would I do eventually? I'd eventually rub it off, right? But what can epithelial tissue do? Regenerate. It can make more of itself. That's how you can remember that. Okay? So there were some other important characteristics of epithelial tissue. They are polar, meaning you can tell the top from the bottom, right? You're always going to have a basement membrane on the bottom surface of the epithelial tissue. The way you recognize it in a picture or under the microscope, the cells are all densely packed together, touching each other. Okay? So if we look at our first picture, this is simple squamous epithelium. Function is what? Allows passage, diffusion. Any of those answers are correct. Let stuff go through. Okay? I heard protection. Why is that a bad answer? Because it's too thin to be protective. Okay, very good. Where do you commonly find this? Lungs and blood vessels. Very good. Okay. This is simple cuboidal epithelia. What's its function? Secretion and absorption. Where is it found? Kidneys. Okay, and there are some others, but mainly kidneys. Ovaries is also a good answer. Simple columnar epithelium, what's its function? Absorption and secretion. All right, I don't think I said it last time. They actually give a name to some of the cells in simple columnar epithelia that are able to secrete mucus, and those are called goblet cells. It's not a big deal right now, but you're going to hear that later on in some of your A&P classes. You'll start hearing goblet cell. You just kind of need to keep it somewhere tucked in the back of your mind that a goblet cell is simple columnar. Okay? Where do we normally see simple columnar epithelium? What system in our body? Digestive structures. Okay, very good. There are in the respiratory some, but mainly digestive. Okay, this is pseudostratified columnar. What is its function? Secretion of and propulsion of what? Mucus. Okay? I actually titled this slide incorrectly. That's not just pseudostratified columnar epithelia. What's the proper name? I heard the answer. Say it loud. Have confidence. Ciliated pseudostratified columnar epithelia. And that cilia is one of your big key features that helps you know that's what you're looking at. When you see simple columnar, you're not going to really see cilia. When you see pseudostratified, you're going to see cilia. Okay? What system do we see this type of tissue? Respiratory. Very good. Okay? This is stratified squamous epithelia. All right? What's its function? Protection. Where is it found? The skin, esophagus, mouth, okay? Vaginal canal. Okay? Transitional epithelium. What's its function? Stretchy. Stretchy. And some of you said storage because where is transitional epithelium? Bladder. Okay, so it's storing our TT. And TT is a scientific term. Okay? All right, next, connective tissue. Where do we find connective tissue? All over the body. Okay? Any place you see epithelial tissue, there's some connective tissue underneath it. Okay? Lining just about everything in our body. Really hard to give a generic function of connective tissue because there are so many different types of connective tissue. Okay? The way you learn your connective tissues, you look for the 3 components of the connective tissue. The 3 components of connective tissue are the ground substance, fibers, and cells. Last time, right as we were leaving class, somebody asked me, is ground substance the same as matrix? Yeah, pretty much. If you like the word matrix better, use the word matrix. Okay, the ground substance is just the background stuff. Okay, the fibers and the cells are in the ground substance, in the matrix. Okay, for something like blood, the ground substance or the matrix is liquidy, right? Because blood is fluid. Something like bone, the ground substance or matrix would be very, very solid, very hard, because that's what we have bone for. Okay? The fibers are going to be collagen, elastic, and or reticular. How do you know it's a collagen fiber? Thick and it's straight. What's the function of collagen? Strength, structure. Okay? What happens to a lady's face when her collagen gets old? She has wrinkles, right? That's because she can't, her collagen's no longer there to give her skin firmness. Okay? Now the collagen's in the connective tissue, right? Okay? So if I take all those $100 creams and rub it on my epithelial tissue on the outside, is that going to make my wrinkles go away? No, save you money. If you want to get your wrinkles go away, put hemorrhoid cream on your face. It'll work a whole lot better than those expensive creams. Okay? Doesn't smell good though. All right. My husband makes fun of me, but it really does work around your eyes. Your grandma never taught you that, ladies? And yeah, hemorrhoid cream around the eyes. It makes your eyes perky. Okay? All right. Next is elastic fiber. What's it look like? Now you're all looking at me thinking, God, she put hemorrhoid cream on her eyes. Don't do that. Don't do that. Don't do that. That's bad. Don't do that. That's bad. Very different. Very, very different. Yeah, don't do that. Yeah, just telling y'all, don't do that. That's bad. Well, I'm sorry. I get on my little sidetrack thing. Go ahead. You have a question? Okay, sorry. All right. So, what does elastic fiber look like? Stretchy, long, and skinny. What's its function? Stretch. Okay. You also have elastic fibers in your skin. When you get wrinkles, it can also be because your elasticity of your skin is gone. And that's more of your drooping type of wrinkles. When people get like what I call like bulldog jowls, you know, when they get older, that's because they've lost the elasticity around their chin. Okay? And the third type, reticular, what does it look like? Tree branching. Okay, very good. Kind of a mixture. Strong, a little stretchy. Okay? Cells we name by the type of tissue we're looking at. If it's connective tissue proper, which were the ones we looked at last time, it's called a fibroblast. If it's cartilage, chondroblast, chondrocyte. Bone, osteoblast, osteocyte. What is the difference between a blast and a cyte? The age of the cell, maturity. Okay? Can you look at them in the microscope or one of those pictures and tell the difference? No, absolutely not. I would never expect you to. Okay? So last time I think we did the loose connective tissue. Is that what y'all told me? Okay? So this one is areolar connective tissue. The matrix or ground substance is the white in the background. You can see collagen fibers and elastic fibers. Those dark purple dots are the nuclei of fibroblasts. How do I know they're fibroblasts? Because this is just plain connective tissue. So the cells are going to be fibroblasts. What is the function of areolar connective tissue? It's a cushioning. Okay? It provides strength to wrap around your organs. Okay? Where do we see this at? Main place? Under the skin. It's the second layer of your skin. Very good. Some of you are ready to answer me. Okay, next is adipose tissue. Okay, what are the big white globs in that picture right there? That's the fat inside of the adipocytes, the fat cells that have swollen up to store the fat. What's the function of fat tissue in your body, adipose? Insulation, protection, and storage of potential energy, stuff you can make energy out of. Very good. Where do you find fat? Find it everywhere, but it's around your kidneys, your eyeballs, usually more centered around the abdomen. Some people more centered around the hiney region. I'm trying to think of the proper term. The gluteal region. I'm in a just a goofy mood today. I'm sorry. Okay, last one we did last time was reticular. Okay, when I look at this, I see tree branches. So what am I looking at? Reticular fibers, right? All right, where's the only place in your body you see reticular tissue? Lymphatic immune system organs. Okay, lymphoid organs. Very good. This is where we left off, with dense, regular connective tissue. How do I know it's dense? Do you see the ground substance or the matrix? No, the fibers are all pretty stuck together, right? This is regular because it has a repeating pattern. Anytime you see that wave-like look and the little smush nuclei, you know you're looking at dense, regular connective tissue. What type of cell is that nuclei from? Fibroblast. Good. I didn't hear who said it, but how do you know that's the answer? This is plain old connective tissue, right? It's always going to be a fibroblast. The dense, regular connective tissue is found only in your tendons and your ligaments, okay? Mainly made of collagen fibers. So what do you think its function is? Why do you have tendons and ligaments? Attaches your muscle to your bone. Do you want that to be something that'll just flip and bend all around in all directions? No, you kind of want it to hold in place. You don't want it to be too firm though, right? Or it would pop and break too easy. So you want it to provide what we call tensile strength, meaning you can pull on it and it'll give just enough that it can stay strong but keep everything where it needs to be. Now, which direction is it going to provide strength? Any direction I want to pull? No. It's only going to be strong if I grab here and pull, right? If I grab top and bottom and pull, I could pull it apart, okay? So have you ever heard of somebody messing up a ligament in their knee or their elbow or something like that? That's because they bent and pulled their bone or muscle in a direction it wasn't supposed to go. And that's how you tear a ligament. You pull it in the wrong direction. That would probably hurt. Okay, I've never had it happen, but that would probably hurt. Okay, that's dense regular. This is dense irregular connective tissue. Okay, how does that look different? Doesn't have the repeated pattern, right? You don't see the nice little waves. How do I still know it's dense? You don't see large areas of ground substance or matrix. There's not a lot of white in the background. Very good. Dense, regular connective tissue can provide you that same tensile strength, but not in just one direction. You can pull on this in lots of directions, and it's still going to have some strength to it. Main place you're going to see this is the next layer of your skin. So far we've already learned a lot about skin, right? The top of your skin is epithelial, stratified squamous. Then we have areolar. Then underneath you have dense, irregular connective tissue. Okay? Just gives your skin some strength. There's other places too, but that's your main location. Okay? Next tissue, dense, elastic connective tissue. Why is it dense? Because everything's touching. All the fibers are touching. How do you know it's elastic and not dense regular? How does it look different? It's tighter. You can see the fibers. And what do the fibers look like? So here the fibers were thick and pink, right? What do the fibers look like now? Thin, dark, and wiggly. So it's elastic fibers, right? So what do you think is going to be the function of this? It's going to be able to stretch like crazy. You can grab this tissue and pull it and stretch it really, really far in one direction, and it'll always recoil and pop right back where it's supposed to. We're going to see this tissue in blood vessels, our lungs, and also in part of our vertebrae. And as we go through the next parts of the course, you'll see exactly why you have it in all those places. Okay? All right. So that was our connective tissue. It's going to be loose or dense. So you have to see, can I see ground substance or can I not? And you identify it mainly by the type of fiber you're looking at. Okay. Now we have the next type of connective tissue, which is cartilage. Cartilage looks, when you look at cartilage, you can see what looks like little eyeballs. Okay? The way you tell them apart is by what type of fibers you can see. Okay? So we're going to start with hyaline cartilage. Do you guys see what I mean by it looks like little eyeballs? Okay? Those eyeballs have names. Okay? The little white house, the white part of the eyeball, is called a lacunae. Okay? And then what you would think of as like the pupil of the eyeball, the dark part in the center, that is a cell. What do we call cells that are found in cartilage? Chondrocytes or chondroblasts. Good. Okay. Now the way I know this is hyaline cartilage is when I look at the matrix in the background, I can't see the fibers. There are some there. You just can't see them. So if all you see is kind of a solid colored background with eyeballs looking at you, it's hyaline cartilage. Hyaline cartilage is the most common type of cartilage. Okay? It's really good for providing some cushion. It's not too hard. It's not too soft. You're going to see hyaline cartilage when we go over the skeletal system because the end of every long bone in your body has hyaline cartilage on it. Okay? You also have hyaline cartilage in your ribs, okay? End of your nose, as well as in the trachea and the larynx. Okay? So if you grab the end of your nose, how firm is it? It's pretty firm, but can I wiggle it? Right? I can wiggle that. Compared to your ear is not hyaline cartilage. Can you feel how they feel? Y'all can do it too, so I don't look stupid. Can you feel how they feel different? Okay? The ear's a little firmer, but the ear can bend a whole lot more than the nose can bend, right? All right, I can flip my ear all the way down and fold it forward. Can I flip my nose all the way over? No. So the hyaline's kind of in between. It has a little bit of movement, but it's also firm enough that it can provide some structure for us. Other place we have hyaline cartilage we don't get to talk about until A&P 2 is the embryonic skeleton. Okay? When a baby is first developing inside of a mother's womb, the entire skeleton first develops as hyaline cartilage. And then the hyaline cartilage grows and then is replaced by bone. A baby skeleton is not completely replaced, though, by bone until they are almost 2 years old. They're still going to have pieces of their skeleton that are hyaline cartilage. Does anybody know why? Why does the baby have all those soft... Well, they're more accident prone, so when they fall, they don't break a bone. But what about the day they're born? Why do you not want it to be... Because that baby's got to come out, all right? So when a baby comes out, their head can actually smush together because their bones are not one solid skull bone. It's got some hyaline cartilage in there, so it's more flexible. That's why babies can come out looking crazy cone-headed, and then it can go down, because my child was scary when she was first born. The first thing my husband said to me the day our daughter was born, he looked at me, you know, some dads cry, and they're just like so emotional. My husband looked at me and said, is her head going to stay like that? But it didn't. She's beautiful now. That was the first thing my husband said to me after I had just birthed our child. So men, don't mess up. That wasn't good. That wasn't the right thing to say. All right. So we got it. Hyaline cartilage. Next is elastic cartilage. Do you see the lacunae? See the eyeballs? See the chondrocytes inside of the lacunae? All right, now tell me how this picture looks different than the hyaline cartilage. You can see stuff in the background. You can see little black skinny fibers. So guess what type of fibers those are? Elastic fibers. Okay? Elastic means stretch, right? So what's the function of this type of cartilage going to be? It's going to provide more stretch while it's still providing structure. So it's stretchier than the hyaline cartilage. I already told you one place we have this is our ear, outside part of our ear. Only other place we have this is called the epiglottis. That's a little flap down the bottom of your throat that makes your food go one way and your air go the other. We'll talk about it more a little later. Okay? Last type of Last type of cartilage is fibrocartilage. Okay. Do you see the lacunae and the chondrocytes? A little harder to see. I don't know why your textbook does it, but this is lower power than the other pictures. These little guys right here, that's the lacunae, that's the little cell. That's the lacunae, that's the chondrocyte. So it's just lower magnification than the previous pictures. What does this look like to you when you look at it? Fish in the ocean, right? And like ocean waves. Even if it wasn't blue, couldn't you still see the ocean waves? That's how I always remember that this was what fibrocartilage looked like. Fibrocartilage gives us the greatest resistance to compressive shock. And how can we remember that? Well, let me tell you where we have fibrocartilage. In between our vertebral disc and in our knee, and also our pubic symphysis, which is where the two pubic bones come together. Do your knees take a lot of shock every day? Absolutely, right? If I jump up and down, my legs don't break because I've got nice big pieces of fibrocartilage in my knees. Okay? Fibrocartilage is so tough, while we're talking about having babies, let me tell you this. When women have a child, men like to say their hips spread. They literally do. In order for a baby to come through the birth canal, the hip bones break at the site of the fibrocartilage and open, let the baby out, but they close back and the fibrocartilage heals itself. Okay? Up to about 3 children, you can tell how many children a woman has had because you can see the scars where her fibrocartilage has ripped open and gone back together. After about 3, the scars start to overlap or either the hips stay open. Because I guess the body decides she's going to keep popping kids out. I don't know, leave this open. But, so if you've never had kids, I don't tell you that to scare you. You don't feel it. Okay, so much, well, I mean, you feel so much at the time. It's not like all of a sudden, pop, there it went. It slowly opens to get ready. What if you have what now? There's something wrong in your head, too, not just your hips if you have 18 kids. Yeah, I mean, it's probably going to be permanently open. Like, her hips are never going to fit into the same pair of jeans they fit into before she had her first one. So, those of you who've never had children, this is what you have to look forward to. Your hips are going to pop and break open. But they've invented epidural. You don't feel nothing. All right? Keep going. I'm trying to make this even remotely interesting while we're looking at these pictures, if y'all can't tell. All right, next is bone. We're still in connective tissue, right? Okay. Now, when we look at bone, we see, oh, you see spider webs. Oh, I see that. Good. Usually people say tree trunks, but I totally see the spider web too. Okay. What type of cells are going to be in this? Osteocytes, osteoblasts. Okay. What is the function of bone? Support, some protection. Hardest question on the test. Where is bone tissue found? In the bone. Can you believe people miss that on exams? They do. Okay? All right. Please don't be one of those people. Okay? Blood. When I look at this picture, what do I see? Perfectly clear ground substance or matrix, right? Cells, which are called blood cells. There's red blood cells. Those are the pink ones. And then the white blood cells are those big old cells. Okay, and we'll talk more about those in A&P too. What does our blood do for us? It carries oxygen. What else does it carry? Red blood cells carry the oxygen. White blood cells are part of our immune system. Good. Waste. Sugar. So give me one word. What does it do? Transports. It carries stuff through our body. Okay, very good. All right, another question you should not miss on the test. Where is blood found? In the blood vessels everywhere in your body except cartilage. Cartilage is the only place in your body you don't have blood. Oh, and epithelial tissue. Okay? Other than that, you got blood vessels flowing through it. Okay, good. Next is nervous tissue. Okay? What do you see when you look at that picture? Kites. I see kites. I don't know what y'all see. Okay. The kites are called neurons. Those are the actual nerve cells. The big long extensions coming out of it are arms of the nerve cells. Nerve cells are special because they can talk to each other. One nerve cell can send a signal through that arm and tell the other nerve cell something. So what's the function of nervous tissue? Transmitting signals. Communication. Okay? One of the most important things that our body is able to do. Where do we find nervous tissue? Brain, spinal cord, and nerves. That's all we're going to say about nervous tissue until we get to the end of A&P 1. And we'll talk a lot more about it. Okay? The last thing in this chapter is muscle tissue. Okay? Muscle tissue fits into one of three categories. It can be skeletal, smooth, or cardiac. Okay? Skeletal muscle is voluntary. What does that mean? What does voluntary mean? You have to tell it to move. Your brain decides when you're going to kick your leg. You're not just standing there and all of a sudden your leg starts randomly kicking, right? Okay, something would look funny. Okay, they are striated. What does striated mean? It's got stripes. Okay. When we get to the chapter on muscle tissue, we're going to learn exactly why it looks striped. But for now, you just need to recognize that it has that striped appearance. Okay? It is multinucleate. So that means when we're looking at this, this is one long cell. And it has all these nuclei in one different cell. Again, we're going to learn why a little later. Okay? So how are you going to recognize this as skeletal muscle? It's striped, and all the cells are perfectly parallel to each other. You see that? None of the cells are crossing over each other. One is perfectly stacked on top of the other. Okay? Where do you find skeletal muscle? Attached to your bones. What's the function of skeletal muscle? Movement. Okay, very good. Okay, this is cardiac muscle. How does it look similar to skeletal muscle? Striped. How does it look different? The cells aren't perfectly stacked on top of each other. Good. The cells are what we call branched. So if you try to follow one cell, here's a cell and it branched here and it branched there. But what did I tell you in lab? Does anybody remember what the easiest way was to tell you're looking at cardiac muscle? Those lines. Those are called intercalated discs. That is the easiest way to know you're looking at cardiac muscle. Is cardiac muscle voluntary or involuntary? Involuntary. You don't have to tell your heart to beat. It does it on its own. Okay? Where is cardiac muscle found? In the heart. Very good. It actually, walls of the heart is the right answer. It's not in the heart. There's nothing in the heart. The heart's empty. Blood floating through it. Okay? All right? Last one is smooth muscle. How does it look the same as either of the other two? It don't have stripes. You're seeing lines that are running this way, right? Stripes running up and down. It's not striated. Are the cells perfectly parallel sitting on top of each other? No. The cells are what we call spindle-shaped. A spindle looks like this. Okay, so you'll have one cell, and then the next cell's kind of sitting here, and then here. And they just kind of stack on top of each other. Now, is smooth muscle voluntary or involuntary? Involuntary. Smooth muscle is found in your internal organs like your intestines. You don't have to tell those to contract and move. Okay? I'm going to give you a little bit of a warning. Two of the most commonly mixed up tissues are smooth muscle and dense regular connective tissue. So make sure when you're studying you can tell the difference between those. Dense regular has a wave, okay? And then smooth muscle doesn't have a wave. All the cells are touching each other. I'll be honest with you guys, I think this is one of the hardest ones because it doesn't really look like anything. So you can't just come up with something cheesy that it looks like. Okay? So here's what we're going to do the rest of the class period today. We're going to practice.